let us consider smallest change for this categories, which is having the smallest change. 2001 kitchen 20%, whereas 2009 14%. 20% of 17,000 minus 14% of 15,000. So there seems to be a drastic change. 1 percentage reduced, 2 number also reduced. Next, print room. 15% of 17,000 minus print room here is 12%. 12% of 15,000. Percentage reduced, number also reduced. Okay. Next, meeting room. Meeting room was 12% of 17,000 minus meeting room here is 14%. 14% of 15,000. So percentage increased. So the value must be smaller. Right? Change must be smaller. Okay. Next, PC room. For PC room, 12%. 12% of 17,000 minus PC room there is 21%. 21% of 15,000. So the comparison, if you have to do, I'll go with these two choices, right? Why? Because just by looking at the percentage increased and the number reduced, so change will not be much. So 12% is going by the previous logic. 12% of this, if I subtract, what am I left out with? Just 2%, right? So 12% of 15,000 plus 2,000 minus 12 plus 2% of 15,000, right? This is what I am doing, which is equal to 12% of 15,000, 12% of 15,000. That gets cancelled out. 12% of 2,000 minus 2% of 15,000. 12% of 2,000, 10% is 200, 1% is 20, 1% is 20, 2% is 40. So 240. 2% of 15,000. 1% is 150. 1% is 150, 2% is 300. We just bothered about the change. So I'll go with this. So change is 60. Whereas here it is 60. Okay. I'll consider 12% of 15,000 plus 2,000. 12 plus 9% of 15,000. So difference, 12% of 15,000, 12% of 15,000, that gets cancelled out. So 12% of 2,000 with compared to 9% of 15,000. Right? $240 10% of 10,000 is 1,500. 1,500 minus 1%. 1%, 150. 1,500 minus 1, 1,350. Right? 1,350. This is a drastic change. Right? So the answer I go with is C. You need not check each and every one. Going by some smart guess, you can eliminate some choices. Right? Next, let us consider last but not least permutation and combinations. Okay, I have written combinations first, permutations later, because in combinations order is not important. In this case, order is important. Okay, let us say your expectation let us say you expected 90 percentile, whereas you achieved 95 percentile. You achieved more than what you expected. You achieved more than what you expected. Then what will be remediate reaction? Party. You see what is the amount left in your pockets, and assuming you don't have credit cards and you don't have somebody who is offering you immediate credit. Okay, let us say with the amount that you are left out with, you chart out the friends and relatives, right? So going by close friends, how many close friends you have? Let us say you have 5 very close friends. Then relatives who are as close as any of these friends. Please understand, relatives who are as close as any of these friends. Why am I using this condition? Because everybody has got an equal chance for being selected. So what is the assumption? Everybody has got equal chance for being selected. Everybody has got an equal chance for being selected. So using that logic only, I am talking about any relative has got an equal chance for being in the party, or any relative is as good as any friend, right? Okay, when you chart it down, you have 5 close friends and relatives from whom you want to list out how many you want to invite, going by the pocket size. Okay, let us say you have concluded that you are going to invite only 6 people. So very basic question, select 6 people out of 5 friends and 3 relatives for party. So in how many ways you can do this? Anybody has got an equal chance for being in the party, so you don't need to distinguish friend with a relative. So put together it is 8. Out of 8 you want to select 6. You select 6 out of 8. This we represent it as 8C6, right? So that is choose 6 out of 8. This is what you understand from this. Going by NCR, you choose R out of N. It is given by N factorial by R factorial into N minus R factorial. By the way, what is factorial? You subtract. Factorial is defined only for natural numbers. Factorial is defined only for whole numbers. You subtract 1 till you get 1. Okay. Okay. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. But how about 0 factorial? You say it is 1, but how? Very simple. Here you are selecting 6 out of 8. Suppose the other two get to know about this party, then there is every chance that those two will not be meeting you again. If you don't want to take that risk, then you are left with no option but to invite everybody. If you have to invite everybody, select 8 out of 8. In how many ways you can do that? Which can be done in just one way, right? 8 people, you want 8. There is only one way in which you can select, right? That is NCN is equal to 1, or we can say n factorial by n minus n factorial into n factorial, it is equal to 1. N factorial gets cancelled out. 0 factorial is equal to 1. This is how you prove. By the way, if you consider factorial as a function, domain and range will be interesting to consider. What is the domain of a factorial? That means what are all values that can be considered as input of a function. This is a set. This is also set. Okay. What are all values you can consider as an input for this function? Whole numbers. 0, 1, 2, 3, 4, n. Any whole number can be considered as an input. What is the output? What is the output? We have considered 0 factorial is equal to 1, 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is equal to 6, so on. Right? It is a set of natural numbers, right? So range, if you say R, it is a set of natural numbers. It is a subset. Next, if you consider combination as a function, what can be considered as an input? For that, we have to consider n, c, r. N input, r input. For n, you can consider any natural number. For r, you can consider any whole number less than or equal to n. So range, domain of this is defined by domain of n. Okay. Coming to range. Range can be any natural number. Let us make this more interesting. Select 6 people in such a way that there are more friends than relatives. All relatives must be in the party. All friends must be in the party. Find out the number of ways in which you can do first case, second case, third case. Try this problem. Okay. Let us consider third case. All friends must be in the party. If all friends must be in the party, 5 out of 5 selection is done. There is only one fellow to be selected. That one fellow must be a relative, right? So 1 out of 3, that is 3C1, 3 ways. So only in 3 ways you can satisfy this condition. Next, consider this case. All relatives must be in the party. So 3 are already selected. You need how many more? 3 more. So 3 out of 5. So 3 out of 5, that is 5C3, 10 ways. Next, there are more friends than relatives. Friends should be more than relatives. Look at the different possibilities. What are the possibilities? All friends, one relative, right? This is possible. Or I would say 5 friends and 1 relative. Or 4 friends and 2 relatives. Is there any other possibility? 3 friends, relatives? Not possible, because more friends than relatives. This is possible or this is possible. Now 5 friends and 1 relative. So 5 out of 5 and 1 relative. So this is already discussed. It is done in, I would say, 5C5, and for each of these possibilities, for each of these combinations, what are the combinations? Right? When you say this is possible, this should happen, you need 5 friends and you need 1 relative. That means for any number of these possibilities, what are the combinations with this? Right? You can write like this or like this. Both are same. Now in this case, 4 friends and 2 relatives. You want 4 out of 5. In how many ways you can select? 5 ways. For each of those possibilities, in how many ways you can select 2 relatives? Right? 15 plus 3, 18 ways. You observe here, these are basically conditions. When there was no condition, it was simply 8C5. If you apply conditions, the answer will be less than 8C5 or at the maximum equal to. It can't be more than that. That is one more way in which you can cross-check your answer. Okay. Now let us say you have invited your friends and relatives, including yourself. 5 gents, 4 ladies. Okay. Each person gives a handshake once to every other person in a party. Find the total number of possible handshakes. Try this problem. Okay. 5 gents and 4 ladies are in a party. Each person gives a handshake once to every other person in the party. You want to know how many possible handshakes. Right. Now, if you go into a handshake, basically for a handshake to happen, you need 2 people. Right? So, if you have 2 people, a handshake is possible. So, number of handshakes possible is as good as number of ways in which you can select two out of 5 gents and 4 ladies, that is 9 people, which is nothing but 9C2, right? We can generalize this. If there are n people, nC2 number of handshakes. There is one more way in which you can understand. Let us say the first person will be giving handshakes to remaining 8 people. Second person has already received handshake from the first person, or he shook hands with the first person, so he will be shaking hands with 7 more people. Third person has already shook hands with first and second, so he will be shaking hands with 6, so on. 8th person will be shaking hands with 9th person. So it is sum of first n natural numbers, sum of first n natural numbers till 8. So n into n plus 1 by 2, sum of first n natural numbers. So here it is 8 into 9 by 2. So 8 into 9 by 2, this is when there are n people. This is when there are 9 people. So in case of n people, it is n minus 1 into n by 2. Okay. Okay. Find the number of triangles possible which can be considered which can be drawn using vertices of octagon. Try this problem. Find the number of triangles possible which can be drawn using vertices of octagon. Octagon has 8 vertices. To draw a triangle you need 3 vertices. So if you can select any 3 out of 8, you can draw an octagon. Right? So you can generalize NC3. Let us take a similar question. Find the number of diagonals in an octagon. Try this problem. Okay. Now when you consider number of diagonals in an octagon, what is a diagonal? Diagonal is a line joining vertices two vertices which are not adjacent. By the way, in an octagon there are 8 vertices. You choose any 2 vertices, what are you going to get? You get number of lines. Are all lines diagonals? No, that's what the diagonal definition says. Now what happens if you join two vertices which are adjacent? You get a side. It is not a diagonal, right? So two vertices which are adjacent, if you join, you get a side, right? By the way, this is not octagon, but to understand. So there are 8 sides, right? Which means adjacent is ruled out. So 8c2 minus 8 will give you what? Number of diagonals. So if you wish to generalize this, how to generalize? nc2 minus n is number of diagonals. You don't need to simplify this. Please don't do that. Not required. This will give you the number of diagonals. Let us take a short break. After break, we'll be continuing with combinations.